Okay, I apologize for the two separate videos, but I was accidentally recording in 4K, and those videos are only limited to 10 minutes in length. So, starting where we left off, talking about in the steady state and the unsteady state method, there's a problem, and it's called the capillary and effect. And pretty much what this is it's the problem stems from the saturation discontinuity at the outlet face of the core sample. And this can force errors in the calculating of relative permeability. And uh, in addition to the capillary effect, there's other factors that affect your relative permeability measurements. And there's quite a bit of evidence that relative permeability is more than just fluid saturation of the porous medium or the core sample. And some of these include the saturation history, the magnitude of initial phase saturation, the wettability, effect of rock pore structure, the overburden stress, clay and fines content, temperature, the interfacial tension or IFT, viscosity, and displacement rates. Um, Also, there's a peculiarity of relevant relative permeability data, and it happens in um the the um the USS method or the unsteady state method, and it just pretty much happens where there is um there's a simultaneous point in two phase production, so oil and water saturation, where in the oil and water saturation, where the two phase production is absent. So, and it's better described as a graph. So you can see at this point, there's no oil production um, after the water starts, and the water doesn't start till down here, so that leaves a weird little point of um, just weirdness there, and it makes it not possible to complete the permeability curve when you have this little point here. Um, there's there's a lot of kind of issues you can see with the relative permeability, and there's an equation for assessing the validity of relative permeability um, data, and it is the normalized saturations is equal to the 1 minus the given water saturation minus the residual oils saturation over 1 minus irreducible water saturation. Oh, what am I doing? Which stands for SWI, and subtract that from the residual I can't say that word, and I'm writing it again. The residual oil saturation, which I set up there. That's a little messy. So yeah, and then you might be asking at this point, um, what does this mean? What does this whole relative permeability mean? Like, obviously that it's the effective permeability over the absolute permeability, but it just pretty much means it's the direct ability of the core sample to conduct fluid phases when they share the same pore space, specifically gas and oil, and then water and oil. And then this brings us to that, and because gas and oil and water and oil is two-phase permeability, but we start talking about three-phase. Things start to get kind of messy. You need three-phase relative permeability is basically when there's a simultaneous flow of oil and gas and water in your porous medium instead of just gas and oil and water and oil. And this is tough to measure because there's an infinite number of displacement paths. So in the petroleum industry, what they do now is they use the two-phase method using the steady state and unsteady state methods earlier described, and they put them and they generate three-phase relative permeability using empirical models. And one way to do this is the three-phase ternary diagram, which looks like this. So pretty much you have your three corners of this triangle, and the top is 100% 100% gas. Then we have 100% water and 100% oil. And kind of on the opposite ends, you have the 0%, 0%, and 0%. And when you take your two-phase measurements, you can get a couple of plot lines, and they kind of go like this. And I'm not really sure what it means. This whole three-phase part really, this whole chapter confused me, but mainly the three-phase part really threw me for a loop, because then we have the stone methods, which there's the stone 1 or the stone model, the stone 1 model and the stone 2 model. And I know the stone 1 is for normalized saturations, and like for example, we have the gas saturation is equal to the, so I'll write the equation first. And yeah, it's pretty much, it's just the gas saturation is equal to the oil saturation over 1 minus the irreducible water saturation subtracted by the, I think it's water saturation, but I'm not sure. And then you have the Stone 2 method, which I have no idea. I have no idea what it means. But that concludes my presentation. Sorry about it being a little messy and stuff. And I hope you learn more from the PowerPoints than you did from my lecture. And I hope you have a good day. Thank you. Goodbye.